All right, all the problems that you had for this last assignment were all polynomials, some type of simplifying polynomials. It could have been multiplying polynomials, adding polynomials, combining polynomials that had exponents. So there's a couple different versions of problems that you could have seen. The first one is dealing with multiplying two monomials. So first off, when we're doing this, you want to multiply any values that are out in front, so any coefficients. Here we have a negative, so we have a -1 as our coefficient in the first term, although there's not one there. Again, it's -1 and a +4. So we're multiplying those two together first. So we got -1 and, whoa, sorry. For some reason, it lagged on me and that's not how I meant to write that. Let's try that again. So -1 times 4. So we're multiplying the coefficients. Then we're multiplying the variables. So we have f to the 8 and f to the 12. I think there's one f normal and one fancy, but -1 times 4 is -4. When we multiply variables, how do we do that? So we're going to end up with f to the, no. So if we multiply, so this goes back to properties of exponents. When you multiply values with the same base, you add their exponents. So we have f to the 8 and f to the 12. We're going to add those. So that's going to be f to the 20th. So our final answer is -4 f to the 20th. And that would be our answer. Again, anytime we have any type of exponents, you add them. Because remember, when you have an exponent, that's saying you're multiplying that value by itself that many times. So you have f 8 times there. Then we had f 12 times. We have a total of 20 f's. So it's f to the 20th power. All right, go on to number 7. So this one had 3 different monomials. Multiply again, the lead coefficient is first. So I'm rearranging the order. And if you don't want to rewrite it each time, you don't have to. I'm just doing it for the sake of showing the work. So I'm grouping the coefficients first. Then I group my a values. So I have a to the 3rd. I had a, which it doesn't have an exponent, so it's really to the 1st power. And then a to the 2nd power. Then all the b's, b to the 2nd, b to the 7th, and b to the 4th. So multiplying those coefficients, 6 times 4 is 24. 24 times 2 is 48. And hold on one second.
Keep that in here until it's toward the end.
Yes. All right. So again, we have 48. Now, one out of those 3 terms was negative. So because we have an odd number of negative signs, this is a -48. The a values, we have a to the 3rd, a to the 1st, a to the 2nd. Again, adding all those exponents up. I added the 1 on that middle a value because, and we still have to add it. There's 1 a there, and it's easy to forget about that one since it didn't have an exponent. So 3 plus 1 plus 2 is a total of 6. So we have 6 a's, or a to the 6th. And then the b's, we had 2, 7, and 4. So adding them all up, 2 and 7 is 9, 9 and 4, it's 13. So we have b to the 13th. That's our final answer. So first, again, we multiply the coefficients, then the a's, then the b's. Again, don't have to do the first step of rewriting it if you don't want to, but that's how you combine them. Any questions there so far on the 2 monomial questions? All right, let's go to number 8. This one was actually adding. So on this one, since we're adding values instead of multiplying, we can only add them if they're like terms. What has to be true in order for them to be like terms? They have to have the same variables and same exponents. So on this one, the ones that are like terms, we have the 3k squared and the 16k squared. Those are like terms. I'm gonna go ahead and group them. And then the other 2 are like terms because they are, they are constants. They don't have a variable. So those 2 would be like terms. So that's how we're grouping them as we're adding them. Now, when we add, if they have a variable that's a like term, we're just adding the numbers that are in front of them. So on this one, when we combine them, we get 3 plus the 16, which is going to give us a total of 19. We still have the same variable. The variable is not changing when we're doing addition. So they had to be like terms. It's still going to be a like term in the end. For the other half of it, again, we had our constants. So we're adding those two together, 5 and 7. That's going to give us a total of 12. So that's our final answer. 19a squared plus 12. Yes. So again, that was from our constants, right? We had the 5 and the 7. Those two, it's going to stay a separate value. So we're still going to have any value that was not a like term has to have its own value in the end when we're doing addition. So all the values that were like terms, we combine. So here we had the k squared and the k squared values. We combine those two. We're going to have a term in the end for those two values. We had the two constants. We added those two. We're going to have a term in the end for those two constants. All right, let's go to the next one. Now this one's talking about perimeter. It says the perimeter of a quadrilateral shape, fenced yard, is, and they give us this entire polynomial that represents the perimeter. 3 sides of the fence have the following lengths: 5a, 10a minus 7, and a squared minus 7. What is the length of the 4th side? So this is what we're trying to find right now. Now let's see. Don't actually like this question, but we're going to go ahead and add up what we know so far because the perimeter is all the sides add together. So let's add what we know. So we have 5a, we have 10, I'm going to put in parentheses for now, 10a minus 7, and we have the a squared minus 7. Combine any of your like terms. Now, I'm not going to rewrite them this time. Looking at them, the first value that would be a like term, or that we should write here, is the a squared. So we have this a squared value. Is there any other a squared? No, that's the only a squared from these values that we have on these sides of that rectangle. So we have a squared. Then we're going to go to the a values. So we have that 5a and we have that 10a. Those two are going to combine. So 5a and 10a gives a total of 15a. Then we have the 7 and this 7, which are constants. -7 and -7 gives a total of -14. Now, this, it's not our answer yet. This is these 3 sides added together. We know that the equation they gave us over here, that's all the sides added together. So if we find the difference between that original equation and the problem and what we just added together, that's going to give us that missing side. So we're going to have 3a squared plus 15a plus 9. And then we're subtracting off what we just came up with there. A squared, 15a, and -14. What you have to be careful of is, since we're now subtracting that polynomial from the other one, this minus sign changes all of these. So we want to distribute that negative to every single one of these values, and we'll put a plus sign between them. So this negative is going to distribute to the a squared, to the 15a, and then to the 14. And then we can change this to a plus sign after we've distributed it. The other thing that we can do down here at the end where we got the 14, we now have minus and negative. So that becomes adding a positive after we had distributed it. So now combine like terms, and we have 2 like terms for each one of those values. So first, going in order, 3a squared and -a squared combined to give us 2a squared. All right, so we added those two together, got the 2a squared. Then we got 15a and -15a. Well, those two actually cancel out completely. So yes, I could write 0a. Do I have to? No, because there's no value there. All right. And then finally, for this last one, 9 and 14, add those two together and we get a total of 23. So since I don't have to write that middle term, my final answer is actually, and that'd be my final answer on that one. So again, the perimeter is the total distance around. So we added up all the parts that we had and then subtracted it from the total to find out what we needed for the other side. All right, number 10. We're back to multiplying. On this one, they gave us a monomial out in front. This entire monomial is being multiplied to this trinomial. We're going to have to use distributive property to distribute to each and every one of these values. So the 2k gets multiplied to both of these. And just like we were doing earlier with the monomials, multiply the coefficient with the coefficient, the k value with the k value. Now, I'm not going to write out that first step each time because we're going to multiply it to each one of these, and it gets kind of messy if we write out all those steps. So 2 times -3, what's that give us? -6, all right? K and k to the third. I mean, k to the, so this has what power on it right now? So, sorry, I forget, you can't see my pen. I can only see on my screen. So this k value has what with it right now as an exponent, that front one? It's just, is there an exponent there? No, so it's like it has a 1. So when we add those, this becomes k to the 4th. All right. Now we take that front value again and distribute to the next part. So 2 times k squared. Well, there's no value out in front of k squared. It's like there's just a 1 there. So 2 times 1 is 2. K to the first times k to the second is k to the third. Again, add those exponents. And finally, 2k times -10. Well, we have a negative. 2 times 10 is 20. And then we still have just that 1k. And that's going to be our final answer. We don't have any other like terms to combine. That's it. On 11. So now we're multiplying two binomials. So it's still distribute, and we're still distributing. Sometimes you might hear this as FOIL. I don't know what Genghis used, but if we are distributing here, we have to distribute both terms. So parts, and then we're distributing the -7 to both parts. So we should end with a total of 4 terms after we multiply. So first, 3x times 4x gives us a total of 12x. Is it just x? X to the second, yeah, because we have, this is x to the first, this is x to the first. Add those exponents, it's now x squared. All right, multiply 3x to the next value, 3x times -7. So 3 times 7 is -21. We still have the x value from the first term. Now in the middle, we have -7 and 4x. -7 and 4, well, that gives us a negative, and it's going to be -28. And we have the x value from that second term. Then we have the 7, the -7, and the -7. Well, 2 negatives when multiplied make a positive, and 7 times 7 is 49. So now we have 4 terms. However, on this type of problem, we might be able to simplify some more. So we have an x squared. We have 2 values in the middle that both just have an x, and we have 1 at the end that's a constant. The 2 in the middle, those are like terms. So we can combine those. So we have -21 and -28. When we combine those, it gives us -49. It's still just x, because when we're combining these through addition or subtraction, the like terms still should have a like value in the end. So it still should have the same variable, same exponent. The beginning number, still 12x squared, didn't change anything there. The end, still plus 49, didn't change anything there. That's our final answer. Now again, there are many ways to teach multiplying a binomial. You can use that method. If you use a different method and you got the same answer, that's fine. I know some people like to do the box. Anybody in here do the box?
Mhm.
Yeah. So again, if you do the box, that's fine. All the boxes is taking those values, making sure you multiply all the terms in the one. 3x and -7 on one side, 4x and -7 on the other side, and just multiply them together, you get the exact same values. You've had 12x squared, you've got -x, and you've got a positive 49. Then you have to set them back up and add them, and you combine any like terms. The two here are like terms. So you combine them, you end up with the same final equation. So either way works, whatever you prefer, whatever style you learned, that's fine. You just have to make sure you multiply every term from the first with every term in the second. All right. On 12, a local deli kept track of sandwiches. This is kind of an odd problem. Local deli kept track of sandwiches. If sold for 3 months, the polynomial below models the number of sandwiches sold, where S represents the number of days. So we have an equation for ham and cheese sandwiches, where S was the number of days. And we have an expression for turkey and cheese, where S was the number of days. Write a polynomial that models the total number of sandwiches that were sold. So what you have to recognize is we're just combining these two. We want to add the total number of ham sandwiches, ham and cheese, and the total number of turkey and cheese sandwiches. So we're just adding those two polynomials together. So it's just recognizing what operation do we have to do between these? It's addition. Now, if you want to write it out, that's fine. You don't actually have to write everything out if you don't want to. You could just add them as they stand. So we can see, we only have that first term of 4s to the third. There's no s to the third in the other equation. So we're going to end up with 4s to the third. Then we have like terms for the two s squared values. So we're going to combine those two, 28s squared and -7s squared. Hold on.